A warm good evening to all my dear students. Welcome to HashLearn Studios. My name is Dheeraj. I am your chemistry teacher for the day, and the topic under discussion is group 16 elements, that's oxygen and some of its compound. And this lecture series belongs to JEE and NEET exclusive lecture series. So quickly moving ahead, to recap what we dealt in the previous class of mine, so that's Tuesday, we looked at phosphorus and its compound. So we had two consecutive classes. In the first class, we saw nitrogen and some of its compounds, and then phosphorus and some of its compounds, and we studied about numerical problems to do with those compounds. So before we move ahead to today's concept under discussion, we will look at the CPP question that I had picked up for you guys. So the question is, lead is most readily dissolved in. So we are asking you, if I have to dissolve lead metal, which acid or which solvent would I be using? So the answer is acetic acid, because in all the other remaining inorganic acids, we know that inorganic acids are definitely much stronger than organic acids, but inorganic acids we end up getting insoluble products. So insoluble products means it is not going to let the lead further dissolve once it forms a insoluble product. Hence we are choosing acetic acid as the answer, guys. So we have Sakshi and Yogesh joining us as of now. Good evening, guys. Welcome to the webinar. And today we'll be looking at group 16th element. This is the first class with group 16 elements, so we'll be restricting our understanding and questions to oxygen and some of oxygen based compounds along with sulfur based compounds. So let's quickly move into the class. Before we move ahead, just like the last episode, here also you'll have two consecutive classes, guys. You'll have this followed by a 15-minute break and the next class. So it is time to get a conclusive and a comprehensive idea of the entire 16th block that we will be dealing with today. So we will quickly move ahead. So we have youthful yak. So let us know if I can address you by a different name. And we have Ria, if that's your name. We have two more people joining us as of this moment. Welcome, guys. A warm good evening to you as well. So let's quickly move ahead. The next slide that you would be seeing is the first question for the day, guys. Quickly go ahead, attack the question. We will then discuss about the question. So the question under discussion is, which of the following is used to remove plutonium from spent nuclear fuel? So you know that nuclear fuel is needed to run the nuclear reactors. So once the nuclear reactors fuel is completely spent, that its energy is completely utilized, how will I remove plutonium? So you have OF2, oxygen difluoride, O2F2, that is dioxygen difluoride, OF3 and O2F3. Which of the compounds can be used to remove or extract plutonium from spent nuclear fuel is the question. You have 7 seconds remaining. Go for it. I can give you a couple of more seconds. So Clockmaster says time's up, but take a couple of more seconds, no issues. So Yogesh gives us the first answer. He says it's 1A, and Sakshi gives us the second answer. She says it's B, and we have Shika joining us. So welcome to the webinar, Shika. So which of the following is used to remove plutonium from spent nuclear fuel? So let's wait for people who have joined us now to give us the answers. Go for it, guys. OF2, O2F2, OF3 and O2F3. Which of it is going to be used? It's a pretty important question. Now you should know that what is the need of extracting plutonium. You know, plutonium is radioactive. So even if slight amounts of radioactive material is left in the used nuclear fuel, you know what happens? It continuously undergoes decay, and the decay leads to emission of harmful radiations like gamma, alpha and beta radiation. So what happens is these radiations are harmful. So we do want to take a chance. So we want to remove or extract as much as salvageable material that we can extract, so that the entire nuclear fuel, the spent nuclear fuel that we are decomposing or we are discarding, will be free of radioactive material. So we have Sakshi White Quail. Okay, let us know your guys, let us know your names. So usernames will be your names by which I can address you with. So let us know if I can address you with your actual name. That would be more preferable, guys. So a couple of you have told it is 1B. Yes, guys, it is indeed 1B. So it is dioxygen difluoride, which can be used to extract plutonium from spent nuclear waste. So it is definitely dioxygen difluoride. So you'll not have a clear-cut reaction available for this because it is a radioactive reaction. So you just have to know with respect to our 16th group material which one is used. So it is dioxygen difluoride. Good. A couple of you gave me the right answer. Now moving ahead to the second question. The second question is, which of the following properties is not correct for ozone? It oxidizes lead sulfide, it oxidizes mercury, it oxidizes mercury, I can change this to magnesium, maybe it oxidizes magnesium, and it cannot act as a bleaching agent. So what is it going to be? It oxidizes lead sulfide, it oxidizes mercury, it oxidizes magnesium, and it cannot act as a bleaching agent. Which one do you think is not right? So go for it. Clock master says 5 more seconds left. So you know the basic attribute of ozone. Ozone can act as what? So we will give you guys a little time. Go for it. Oxidizes lead sulfide, then mercury, then magnesium. I corrected that for you. It's magnesium, and then it cannot act. It cannot act as a bleaching agent, which is the incorrect option with regards to ozone. So Yogesh says it's 2A. Shika says it's C. Sakshi also says it's C. Now, think about it, guys. Think about it. Which is not correct for ozone? Let me start giving you the answers. Ozone definitely will oxidize lead sulfide. So if you take PBS, if it's reacting with ozone, PBS will undergo oxidation to lead sulfide along with the liberation of oxygen. So this is how the reaction is going to be. And will it oxidize mercury? Yes, it definitely oxidizes mercury. O3 will break down into O2 plus O, and you'll have mercury reacting with the nascent oxygen to give us mercurous oxide. So you can balance the reaction this way, and you know what to do next. You can cancel out this. The overall reaction will become O3 plus 2 Hg, giving us Hg2O, Hg2O plus O2. So it definitely oxidizes mercury also. The same holds good to magnesium also. So O3 definitely will be able to oxidize magnesium also. So if you have O3, so O3 plus magnesium, so you'll end up getting magnesium oxide plus oxygen. So you can balance the reaction to make it O2. So you can give it as half O2. You can make it a fully balanced chemical reaction. Now the next one is it cannot act as a bleaching agent. So Sakshi says it cannot act as a bleaching agent is the right answer. Yes, it is the right answer because ozone definitely can act as a bleaching agent as well. So if ozone is a very good oxidizing agent, it simply means it can act as a bleaching agent as well. So bleaching simply means removal of any coloring agents. So oxidation is what is needed to remove the colored material. So if it is a very good oxidizing agent, it can act as a bleaching agent as well, guys. So it is option D. So Sakshi and Yogesh gave us the answer. Think about it, guys. Think about, take a little time, think about it, and make sure you give us the right answer the very first time. So you'll have a little confidence in them. So moving ahead to the third question now. So the third question is, which of the following is formed by the action of water on sodium peroxide? So we are asking you to react water with sodium peroxide, and we are asking you which might probably be formed. Try to write the reaction first and then give us the answer. So that would be more appropriate. So action of water on excuse me, sodium peroxide. So what is it going to be? So if you write the reaction quickly, we'll be able to get the answer. H2, N2, O2 or carbon dioxide. Outrightly you can disregard certain options. So definitely cannot be carbon dioxide and definitely cannot be nitrogen, because carbon dioxide there has to be an element or a compound with C in it, which doesn't, and definitely cannot be nitrogen also. So we have to decide between hydrogen and oxygen. So that way you can eliminate the wrong options without even worrying too much. So what is it going to be? So welcome to the webinar, Preeti. So Preeti has joined us for the third question. So straight away she says H2 is the answer. So we will quickly look at it. Others can meanwhile write the reaction. If I have sodium peroxide, that is Na2O2, sodium peroxide will react with water as per the question. You're going to get NaOH plus O2. So if you want me to balance the reaction, it's going to be Na2O2, 2Na2O2 giving or taking 2 moles of water to give me 4 moles of NaOH and O2. So what gets formed? The gas that gets formed during this reaction is oxygen. So we have Karan who has joined. Karan and Peru joined us on the third question. Welcome to the webinar, guys. So Shika says it's O2, right? And Karan says it's C. Shika C again, Yogesh C, and Peru C. So Ria and Sakshi also says it's C. Yes, it is definitely oxygen. And here is the entire reaction for you. So these are some of the refined and hand-picked questions for you guys. P block element, and as a matter of fact, inorganic chemistry, people feel it is dry and it is too much factual. So you have to remember a big deal of information. It is 100% memory based. No guys, it is not definitely 100% memory based. Out of my experience, I can tell it to you that around 60% of inorganic chemistry needs to be remembered. It is definitely factual. Rest 40 can be made really simple if you have the understanding of the fundamentals. So it is 60:40. Now I'll tell you that 60, yes, it is dependent on memory, but 40% which you think is the dreaded part or the difficult part in inorganic chemistry, that can be easily solved if you know the basic fundamentals. And unlike organic chemistry, inorganic chemistry is much easier, wherein the fundamentals will not take too much time to be mastered. So this is one reaction that you have to know. And good, a couple of you gave me the right answer. So let us quickly proceed to the fourth question. So if you have to look at the fourth question, I'm asking you, which of the following has p pi d pi bonding? So we are asking you, which of the following will form a pi bond between the unhybridized p orbital and the unhybridized d orbital? That's the question under discussion. So NO3 minus, SO32 minus, BO33 minus, and CO32 minus. That's nitrate, sulfite, borate, and carbonate ions. So which one is it going to be? The fourth question. Quickly go for it. So Sakshi says it's 4B. You can take the longer route, but the shorter route is just to keenly observe the elements involved. Once you observe the elements involved, you'll be able to instantaneously give us the answer. So Karan's asking as a question. So Karan asks, so will NCRT be enough for inorganic to crack mains? Yes, up to 80% NCRT will definitely suffice to answer a majority of the JEE mains question. Should not be a problem at all. When it comes to JEE Advanced, I would suggest when it comes to JEE Advanced, you can refer to JD Lee. All that you have to do is take the exact syllabus prescribed by the NTA, that's your National Testing Authority. Take it from them or the website, and you have to just study with respect to the syllabus in your hand and from JD Lee. So JD Lee is strictly, I would prescribe JD Lee for advanced only. NCRT in this case should suffice up till JEE mains. So you can rely only on that for your inorganic chemistry. So Karan, Shika, Peru, they've all given us the right answers, and as a matter of fact, everyone who has answered this question has given it right. So it has to be option B. Straight away I can tell, because there is no d orbitals present in the second row elements. D orbital starts coming into picture only from the third row of elements, and nitrogen, oxygen, boron, oxygen, and carbon, oxygen, they're all in the second row elements. So there's definitely no scope for d orbitals, and d orbitals comes in picture only for sulfur, since it's the third row element. So outrightly I'll be able to tell this is the answer. So these are the kind of questions wherein you can save a lot of time, because you don't have to go back and recall and all of that. You can instantaneously answer this. Good. So here's a little breather for you. The question is, with respect to protonic acid, which of the following statements is correct? So this was the previous class's contest question. So the second class on Tuesday, we had given you this question, guys. So we had asked you, is phosphine more basic than ammonia, phosphine less basic than ammonia, phosphine which is as equally as basic as ammonia, or phosphine is amphoteric, which means it can be both acidic and basic, while NH3 is basic. So the answer is pretty straightforward, which most of you would have guessed. And Preeti gave us the right answer for this previous episode's contest question. Congratulations, Preeti. So we have Preeti joining us today as well. So Preeti has won herself an atom session, which gives her exclusive access to get one of the difficult question or a concept solved by our in-house experts. And the icing on the cake is the question or the concept gets clarified within 20 seconds of posting your, 20 minutes of posting your question. So that's a big deal, guys. So congratulations, Preeti, once again. And I'll take up, people are commenting, I'll take up those comments. Now quickly move on to the next slide. The next slide would be is this class's contest question. Go for it, guys. You'll have 60 seconds of time. So look at the question, analyze the question, and the first one to give us the right answer would be chosen as the winner and will be declared to you guys in the next class of mine, which is shortly arriving with 15 minutes of gap. So here we go. The next slide is the current class's contest question. Go for it. So identify the incorrect statement with respect to ozone. So pretty straightforward question. Ozone is formed in the upper atmosphere by photochemical reaction involving dioxygen. Ozone is more reactive involving dioxygen. Ozone is diamagnetic, whereas dioxygen is paramagnetic. Ozone protects the Earth's inhabitants by absorbing gamma radiation. So which of it is incorrect according to you? You have 30 seconds. Go for it, guys. So Sakshi gives us the first answer. She says it's Z. Peru says it's X. So answers are varying. Guys, mind you, we are talking about the incorrect statement. So don't get carried away. So Pallavi, we have Pallavi joining us here on the contest question. So she also gives us an option. So here we go. So I'll give you a couple of more seconds. So others who have not given us an answer, please give us an answer. Then we will move on to the next question under discussion. So looks like most of you have ended up giving us the answer. So we will move ahead to the next slide, which is the fifth problem assigned for the day. So I want to ask you a question here. What is the product formed when ozone reacts with mercury? So this question will repeat itself in various other forms. So once you understand this question properly, you should be able to answer any question that arises from it. So I'm asking you, in what way ozone and mercury's combination will lead to the product formation. So it's the reaction part. Quickly work from your end and let us know the answers, guys. What is the product formed when ozone reacts with mercury? Yogesh and Peru, both of them say it is 5C. Riya also says it is C. Okay, let's give people a couple of more seconds. We can afford those, no problem. So Preeti says it's 5D and Sakshi says it's C. Ozone trying to react with metallic mercury. So what is it going to be? Sakshi and Shika says it's C. Let me give you the reaction, guys. It is O3 plus metallic mercury reacting to give you mercurous oxide plus oxygen. So this is the reaction, guys. So you might have a doubt between C and D, but you should know that it is not mercuric oxide. It has to be mercurous oxide. So Hg2O is the answer. So good. I think around 95% of you gave us the right answer. That's a good deal. We will move. We will see a couple of paraphrased question. relating to the same concept, you'll be able to use your knowledge there as well. Let's move quickly to the sixth question that we have for you. So the next question that I have is, the test for ozone O3 can be done using which of the metals? So like I said, the previous concepts knowledge will be used here as well. If I have to differentiate maybe between two gases, imagine ozone is one gas and oxygen is the other, or ozone with any other gas present in the atmosphere, how am I going to differentiate between the two, or how am I going to test for the presence of ozone is the question here. So go for it. Is it Au aurum gold, Ag argentum silver, Cu copper, or Hg mercury? So which one is it going to be, guys? Which metal is used to test or differentiate ozone from other gases? So time's up is what the clock master says. Take a couple of seconds and give us the right answer. So Yogesh says it's B, and Preeti D, Riya D, good. Shika says B, Peru D, and Sakshi D. So if you're confused between silver and mercury, no guys, it is 100% based on the previous question's concept. It is definitely Hg, because none of these metals react with ozone. It is Hg which reacts with ozone to form mercurous oxide, just like how I showed it to you in the previous question. So O3 plus 2Hg will give you Hg2O, that's mercurous oxide plus oxygen. So it is mercury only, the only metal that I can use which can react with oxygen to convert, which can react with ozone to convert into a detectable form is mercury. So most of you gave us the right answer. Some were confused between silver. Let me know if I can help you clear it. In what way you thought that silver would be used? So others, Hg is pretty straightforward. So that is why it is the answer, guys. We will move ahead. We will take the question ahead. So the next question is, name the gas that can readily decolorize acidified potassium permanganate solution. Name the gas that can be readily decolorize acidified potassium permanganate solution. So you have carbon dioxide, sulfur dioxide, nitrogen dioxide, and phosphorus pentoxide. So you have to quickly find out which one of it is going to decolorize KMnO4 solution. So you should know what is acidified KMnO4's role, and then you can look at it and you can find a pair for it. That's how it's going to work. So go for it. Sakshi says it's B. Preeti also says it's B. Yogesh says it is A. Let's wait for others to quickly give us the answers. So Riya says it is B. Okay. Shika says it is B. Good. Peru says A. Okay, guys. Since most of you were able to give us the right answer, there's no point in delaying. I'll give you the option. It has to be option B, sulfur dioxide. So sulfur dioxide can readily oxidize potassium permanganate solution. So if you want, I can give you the reaction. So here goes the reaction. So if you take, I'll give you the ionic reaction. That is going to be even more useful to us. So MnO4 minus, so permanganate plus sulfur dioxide in the presence of water, acidified potassium permanganate. So you know this is how water comes into picture. This is by balancing of redox reaction. Gives us acidic medium. What happens? Mn plus 7 converts itself into Mn plus 2. So if you remember that, you can write the reaction on your own. Plus, so you have sulfate. So sulfur dioxide is oxidized to sulfate plus H plus. So if you want to balance the reaction, you can have a quick look. So you can make this 2Mn plus 5S2O, and therefore 5SO4 minus, and 2H2O, therefore 4H plus. So this is the overall reaction wherein sulfur dioxide is acting as a reducing agent, and it is trying to reduce potassium permanganate, which is a very strong oxidizing agent. So the sulfur dioxide here is undergoing oxidation. That is, it is acting as a reducing agent and it is undergoing oxidation. So what about others? So pretty much most of you gave us the right answer. What about the other options that we have? Carbon dioxide. Carbon dioxide is neither oxidizing nor reducing. So completely I can rule out carbon dioxide. It's not of any use to us. Sulfur dioxide, I've told you, is the answer, and I've given you the reaction as well. What about nitrogen dioxide? Yes, nitrogen dioxide is a very strong oxidizing agent. Do not forget, it's a very strong oxidizing agent. And if I have the knowledge that KMnO4 is also a very strong oxidizing agent, one oxidizing agent is not going to react with another one. Therefore, I have to look for the reducing agent. So P2O5, phosphorus pentoxide here again does not have a big role to play, just like carbon dioxide. So you have to juggle between sulfur dioxide and nitrogen dioxide, and sulfur dioxide wins because that is the reducing agent which is going to reduce acidified potassium permanganate. So we have pretty much most of you gave us the right answers. Yogesh, Shika, Ria, Preeti, Sakshi. So all of you gave us the right answer. A couple of them gave me the wrong answer. So that's okay, guys. I hope it was a learning experience for you guys. And Shika has asked us, when will we begin our classes on chemical bonding? So Shika, unfortunately, the first year syllabus was covered a couple of months back, and you have all of our videos uploaded in the HashLearn app. You can log into our HashLearn app and take a look at all of those video classes. So we have covered the concepts at depth. And if you have if you're looking at when will we recap these, yes, in a couple of more weeks we'll be completing the second PU portion. After we complete the 12th standard portion, after we complete the 12th standard portion, we will be taking these concepts again and revising these concepts. So it is going to shortly come. So before the JEE exams, we are planning to pretty much cover all of these, so that it's going to help you in answering the questions in a much confident way. I hope I've answered your question. So moving ahead, here we go. The 8th question under discussion. So yes, Shika has a doubt. Go ahead, guys. Go ahead, solve this 8th problem. And after I've discussed the 8th problem, I'll take up your question. In which pair of ions both the species contains SS bond? So we're asking you, in which of these compounds, they have given it to you in pairs, in which of these compounds do we have a SS bond? So all of these are anions of acids. So once you have the thorough knowledge of acids given in 16th group, you will be able to answer questions like these without any problem. So in which pair of ions both the species contain SS bond? Take your time, draw the structure. This is going to take you a little time. Draw the structures, and after drawing the structures, you'll be able to figure out where exactly do I have a SS bond in both the ionic species that are available as options. So go for it. Yogesh says it is B. Let's give others a little time, guys. Shika says it is B. Good. So Preeti says it is C. So no problem. Try. Go ahead. Try to draw the structure. And only by drawing the structure you would know. So I would suggest, instead of remembering questions, I would want you guys to remember all of these structures, because it will help you in answering questions even otherwise. So Ria says it is B. Okay, so we will wait for a couple of more people. So we have Pallavi, who didn't answer the previous question for us. Peru, go ahead and try to answer this. Pallavi. So Karan, so we lost Karan, I guess, after the 5th or 6th question. Go ahead, guys, go ahead. Let me know what your concerns are. Go ahead and try to take a shot at the questions. You should be able to answer them. So go for it. So since others are trying, let us not waste time. I'll give you the structure. It is definitely option B. So good. A good number of you said it is option B. I'll give you the structure. That way it will create an impression and you'll not be able to forget so easily. So I'll draw S4O62 minus first. The name of that ion is tetrathionate ion. It comes from tetrathionic acid. So after I remove the 2H plus the acid has to provide, then I get this anion. So the structure is like this. So sulfur will be available in its oxidation state. So minus, and you'll have another sulfur, S double bond O, O minus, and you'll have S. This is how the structure looks like for the first species of option B, tetrathionate ion. And if you want me to draw the second one is pretty straightforward. That's thiosulfate ion. So the thiosulfate ion is this. You'll have S, double bond O, double bond O, O minus, and S minus. So this is thiosulfate ion. So if you look at it, the SS single bond is present here and the SS single bond is present here. So the option is option B. But then I'll just add another piece of information which might help you in answering. If you take this tetrathionate ion into consideration, you have 4 sulfurs, out of which 2 sulfur will be in one oxidation state and the other 2 will be in one more oxidation state. So this sulfur will be in +5 and this sulfur will be in +5 oxidation state, whereas the other 2 joining sulfurs will be in 0 oxidation state. This should not be a problem for you. The other one is also pretty much same. So if they ask you questions regarding oxidation, there is a good possibility of you getting questions regarding oxidation numbers also in complex species like these. So you have to know the in and around data. So when we ask you a question, I always make it a point to give you a little extra information apart from what is asked. That way you will be able to answer a couple of more questions. So that's the intention. Let's quickly move on to the 9th question. When you guys look at the 9th question, I'll answer Shika's doubt here. So look at this question, guys. We're talking about acidity of diprotic acids in aqueous solutions in the increasing order. So have a look at the options. So which type of questions probably might come in the NEET exam? Yes, definitely you'll have questions like these in the upcoming NEET exams. We make it a point to pick questions which are representative in nature. So if I'm trying to look at a question here, the question will need in-depth knowledge of the concepts, and once you can answer questions like these, you can answer questions around these topics as well. So answering these questions will definitely keep you in a very good position to take up your upcoming exams, guys. That I can assure you, because the questions picked are of that level. So you can trust us on that, Shika. We have been doing this for quite some time now and we have proven results. So we can vouch for the questions that we are solving. So you can go ahead and solve them with confidence. So look at the question once again. Sakshi says it's 9A. Yogesh says A. Shika also says it's A. Acidity of a diprotic acid. Acidity of a diprotic acid. It is in the order of what is the question. So we have only 3 elements of 16th group under discussion. It is sulfur S, selenium Se, and tellurium Te. What is it going to be? So simple. I can say that acidic nature is inversely proportional to bond dissociation enthalpy. Bond dissociation enthalpy. And I know that the bond dissociation enthalpy is inversely proportional to bond length. So this is the actual concept, but I can make it even more simpler for you. If you have sulfur, let us assume sulfur is this, and selenium is definitely going to be a little bigger, and tellurium is going to be even bigger. So if it is combining with hydrogen, I'm not going to show you both the hydrogens. Let's assume if it is combining with one hydrogen, so there is a overlap happening. In this case also there is an overlap happening. In this case also there is an overlap happening with hydrogen. If you look at it, the extent of overlap is worse in case of this. So extent of overlap is worse in this case. The extent of overlap is best in this case. So in simple words, if I have a hydrogen and another non-metal combining, when they combine, if their sizes are comparable, the overlap of their orbitals happen to a very larger extent, making the bond really strong. And if the overlap is weak, just like how we have seen in case of hydrogen and tellurium, since the overlap is weak, the bond is weak. If the bond is weak, I can break the bond heterolytically pretty easily, and I can release the H plus easily, increasing its acidity. So this is the concept behind the question, and yes, most of you were able to give us the right answer. It is indeed option A. Tellurium is the biggest, so it's going to be the most acidic, where it will give out H plus easily because the overlap is weaker, bond is weaker. So breaking the bond and releasing H plus becomes very easy. So Riya, Preeti, Shika, Yogesh and Sakshi gave us the right answer. Good guys. So let's quickly move on to the 10th question. The 10th question is, which gas bleaches the colorless flower? Which gas bleaches the colorless flower by reduction while the other by oxidation? And what are the two gases? So we are asking you, we are trying to do bleaching. You know what bleaching is? Removal of color. So one of the gases here does it by reduction, the other does it by oxidation. Which one is it, is the question that we are trying to ask. So Riya has a question here. Let us take up this question, then I'll take up Riya's question here. So quickly look at this 10th question, guys. Let us answer that and then get going with the questions that you guys have. So time's up. Yogesh says it is C. Shika says C. Sakshi also says it is C. Yes, you guys are right. It is indeed C, because sulfur dioxide reacts with water, or it should have moisture, to give H2SO4 and nascent hydrogen. So the nascent hydrogen is the source for reduction. So sulfur dioxide does it by reduction, and the other gas, Cl2 plus H2O, forms HCl plus HOCl. Now this HOCl further breaks down to give HCl plus nascent oxygen. This nascent oxygen is the source for oxidation. So it's pretty straightforward and a simple question. You can remember that sulfur dioxide acts as a reducing agent and does the bleaching work by reduction by providing nascent hydrogen, and chlorine does it by providing nascent oxygen by oxidation. So most of you gave the questions right. Yes, so you have told us an extra information also that the bleaching done by Cl2 is permanent, but bleaching done by SO2 is temporary. Yes, that can also be a probable question, but this is the reaction or mechanism behind how it does its bleaching. So here we go. And to move back to the question that you guys asked, both Preeti and we had Shika, Riya, I guess, Riya, yes, sorry, Riya and Preeti both asked the same question. What if the solution is not aqueous? In absence of aqueous solution, how do they ionize? Now it is pretty simple, guys. You just have to think about one thing. If you take up regular acids, so I'll move back to the question, guys. So the question was this: if you take up regular acids like HCl, HNO3 or H2SO4, it needs aqueous medium to undergo ionization, and only then it will release H plus and the corresponding anion. If you ask me, will they work as an acid in non-aqueous solutions? Definitely they'll not be able to work as acids in non-aqueous solutions. You just have to remember one thing. If I have someone, imagine I have H2S, hydrogen sulfide. When will hydrogen sulfide act as an acid? When I have H plus available. That can be done by immediately dissolving it in water or a polar solvent and releasing two H pluses and a sulfide anion, S2 minus. This is one way. So to answer your question as to how would it ionize if it is not in aqueous medium, if it is not in aqueous medium, I have to do one thing. Since these compounds are polar in nature, it would ionize in polar, but what would it do in non-polar or a non-aqueous solution or non-aqueous medium? I should find a suitable material to remove sulfide. So if I add a material, that is, it can be an element or a compound to remove sulfide, the leftover species has to be 2H plus. It cannot escape as gas as H2. So if I remove sulfide anion from the molecule, the remaining species have to be 2H plus. So it is difficult. Let me tell you, it is quite difficult to ionize these species in non-polar solvents because they would definitely not undergo ionization. But even if I want to make them undergo ionization in non-polar medium, I have to find a source for sulfide ion first, remove sulfide ion, and therefore the left out hydrogen will be present as hydrogen ion. Will it act as an acid? That's a different question. But will I be able to give you H plus? I will definitely be able to give you H plus. So What about diprotic? Diprotic means I'll be able to give you 2H plus. So if you look at monoprotic acids, if you take HCl, it gives only H plus. So monoprotic, diprotic, it will be able to give you 2H plus. And you can take triprotic, phosphoric acid, it will give you 3H plus. So that's mono, di and triprotic for you. So let me know if I've answered your question, guys. Meanwhile, when you let me know, we will proceed to the next question, which is 11th question. Go for it. Sulfur forms the chlorides S2Cl2 and SCl2. Full stop. The equivalent mass of sulfur is SCl2. The equivalent mass is 16 grams per mole. Therefore, the equivalent mass of sulfur in S2Cl2 is. So I just included a stoichiometry question in 16th group elements. This is possible and this makes it even more interesting. So if there is a little calculation to be done, it removes the dryness in the topic. So go for it. So I'm asking you to calculate quickly the equivalent weight of sulfur in S2Cl2. So we can say, Yogesh gives us the first answer. He says it is B. Okay. We can do it in two ways, guys. We can do it in two ways. Listen to my explanation. One is you have to go by definition. What is equivalent mass? Equivalent mass of an element is that mass which reacts or displaces or liberates 1 gram of hydrogen or 8 grams of oxygen or 35 grams of chlorine. So if you look at this compound S2Cl2, you can say S2Cl2, you can quickly tell that there are 2 moles of sulfur. So sulfur is 32 grams, 32 into 2, 64. So 64 grams of sulfur is reacting with, so chlorine is 35.5. So 35.5 into 2, 71 grams of chlorine. So 64 grams of sulfur is reacting with 71 grams of chlorine. As per the definition, equivalent weight is that weight which will react with 35.5 grams of chlorine. So if I cross multiply, I will arrive at 32 grams. Therefore, 32 grams is the answer. This calculation goes by definition of equivalent mass. If you want to know the formula, there's a very famous formula. Weight of one element divided by equivalent weight of another element is equal to weight of the other element divided by the equivalent weight of that element. So we know, if I have to substitute, 64 grams divided by equivalent weight of sulfur. So I'm taking 64 grams of sulfur, equivalent weight of sulfur, I'm intending to find that, and the weight of the other element, chlorine, is 71 grams, and therefore equivalent weight of chlorine is 35.5. If you cross multiply, you will arrive at 32 grams. So you can go by formulae or you can go by the equivalent weight definition which I gave you. Both will lead you to the right answer. It is 32, guys. It's 32 grams. So good. Shika gave us the first answer. So unfortunately, I think others are still working on it. No problem. Let's proceed quickly, guys. Let's proceed. Look at the 12th problem. The 12th problem is sulfur trioxide is dissolved in heavy water to form a compound X. So the hybridization state of sulfur in X is. So we are asking you to dissolve sulfur trioxide in not regular water, heavy water. So go ahead and dissolve. It should be an easy reaction. Then try to find the hybridization state of sulfur. Go for it. Quickly. sp2, sp3, sp and dsp2. Which one is it going to be? sp2, sp3, sp and dsp2. You just have to create a reaction between sulfur trioxide and heavy water. Once you create a reaction, you will be able to form. Instead of, if you think heavy water is difficult, heavy water is D2O. Dideuterium oxide. Instead of dihydrogen oxide, it is dideuterium oxide. Do the same thing as you do for regular water. You should be able to arrive at the reaction. So take sulfur trioxide plus heavy water, D2O, heavy water. It gives you D2SO4. So we have Yogesh telling us the first answer. Shika, yes, both of them say it is B, sp3. Yes, guys, if you look at it, in what hybridization state is S? S is definitely in sp3 hybridization state. It is based on chemical bonding. So S is definitely available in sp3 hybridization state. So D2SO4. If you want, you can draw the structure as well. So you can say I'll have double bond O, OD and OD. So the structure of the molecule will be tetrahedral since the hybridization state is sp3. So this is going to be the structure. Should not take us too much time. Good. So all of you gave me the right answer. Now we will move on. We will move on, guys. We will move on. So this is the last question that I have packed for you guys in this episode. So have a look at it. So we have given you different options and we have given you the trend against the options. You can have a look at it and then we'll be able to give you the answer. So the last question for the day. So let us end this episode on a high note. So Shika is asking, what if it is DSP2? If the hybridization is DSP2, it will be square planar. The structure will be square planar. So if you're asking me what if DSP2, structure will be changing. If you ask me how it is DSP2, maybe we will have to talk about it some other time regarding chemical bonding. So let me know, Rhea. If it is DSP2, the structure has to be square planar. It won't be tetrahedral. So depending on the electronic configuration of sulfur, we will be able to calculate that. Okay. Now looking at this, guys, let us take up this question. Go ahead and try to answer quickly, everyone. HF, HCl, HBr, HI. It is in the increasing acid order. Is it right? First statement is definitely right because I have fluorine, chlorine, bromine and iodine. Like I said, their sizes are increasing. If their sizes are increasing, the bond compatibility or the atom size compatibility will decrease. Therefore, their acidic strength increases down the group. This is already discussed. So option A is right. So that is not the right answer for us for this question. If you look at the second option is H2O, H2S, H2SC and H2TE, increasing pKa values. You should know that for the B option, as pKa value increases, acidity decreases. But if you look at this, acidity should increase. Acidity should increase because it's the same logic. Oxygen is smaller, sulfur is a little bigger, selenium is even more bigger, tellurium is the biggest, and the biggest atom will be able to give away the H plus easily due to weaker bond formation. So B is wrong. It should have been decreasing pKa value, but he says increasing pKa value. So the right answer is B. I'll discuss the other two options also. If you look at the third option, it is ammonia, phosphine, arsine and stibine. So we have hydrides of 15th group, increasing acidic character. Yes, as I move down the 15th group elements from hydrides, ammonia, phosphine, arsine, stibine. As I move down the group, the size of nitrogen, phosphorus, arsenic and antimony goes on increasing. So it decreases its basic character. Decrease in basic character is nothing but increase in acidic character. So option C is also right. If you look at option D, increasing oxidizing power, yes. Carbon, silicon, tin and lead. If you have them, they are also in the increasing order. They will be able to take electrons easily because what is the work of an oxidizing agent? The work of an oxidizing agent is to oxidize. How can I oxidize somebody else? By taking electrons from them. If I take electrons, I should have place to keep the electrons. Therefore, me as an atom should be bigger in size, and that is exactly how it has been depicted, where carbon is the smallest, lead is the biggest, and lead has the highest oxidizing power. So option D is also right. So I've given you the answer for it. Good. A couple of them gave me the right answer. Others, I hope you have followed this, guys. So to quickly summarize, we looked at 16th group elements, oxygen, its compounds, and some of sulfur based compounds also, and numerical problems to do with it. And I hope this class was interesting and informative. So if you have liked this class, please go ahead and share the video among your friends and help them. And the CPP questions have been uploaded. So Passport subscribers, go ahead and start answering the CPP question. And others, you can subscribe to Passport to have access to CPP questions. And the next class of mine will shortly commence. 8:15, the next class of mine will commence, wherein we will be looking at sulfur based compounds at even more depth. So thank you. So it is your chemistry teacher Dheeraj signing off for another 10 minutes. See you very soon, guys.